logarithms. And the easiest way to do that is to first rewrite it as an exponential, which is what we were doing yesterday. So just rewrite this first log as an exponent.
Oh, okay, so it's
So it should be
what?
I'm getting there. Hold on.
To see if I remember 2 to the power of
Give me a second.
no
y
Let's see if I remember.
equals x. All right, so this is it's unusual for us to do this because usually what we plug in is x, but because of the way this is written, it's easier for us to plug in y. So if we plug a -2 right here, that would be 2 to the -2 power. So 2 to the -2 power. If I have 2 to the -2 power, then first thing I want to do is make that happy, right? So that will be 1 over 2 squared, which is 1/4. So this is 1/4.
Wait, how do you do the log again?
How do you do what?
The log again?
You put the little thing at the bottom, the number.
Don't. That's not what we're doing. You can't do this one because it's log base 2, and your calculator doesn't do log base 2. So that's why we're not using our calculators, because you can't. It won't work. So that's why we rewrote it as an exponential, and now we're plugging values in. So this would be -1 goes where the y is, so that would be 2 to the -1 power, which got to move him downstairs. He's unhappy about his upstairs apartment.
-2.
1 over 2.
And then do it 1 over
Right? Okay.
This is promising.
All right. How many times are we going to miss this one? 2 to the 0 power.
1.
Yes.
That was like so directed.
Oh, it was not. No, believe me, that was directed towards many people. How many of you have missed that one on a quiz?
Probably.
The first quiz we took that had those on there, I think probably 4 or 5 people missed that. Okay, this is 2 to the first power. 2 to the second power. 2 to the third power.
8.
Randy said 2, the 4th, or 2.
Now we can graph this.
Don't go like that. I'll start crying. What pissed in your Cheerios this morning, Randy? Fine, baby.
All right. So it looks like that.
Hold on. I'm dropping the points.
You munching over there?
No.
Aren't you supposed to be eating in every
It tells me in this little box that this graph can be considered a parent function. But the reason that's in quotations like that is because of the same reason I talked about the exponential yesterday. Because we can change the bases, there isn't a specific base that we use as a parent function. A lot of times we use base 2, but that's why sometimes somebody else might use base 10 or base 5 or whatever, and so it might look a little bit different, but not much. So what would the domain of this function be?
0, infinity.
0 to infinity. The 0 is not included because it will never touch that 0. It's got an asymptote there.
Oh wait, I think I did that wrong though.
What about the range?
Negative,
Negative infinity to positive infinity.
Good.
Is everybody okay?
Yeah.
All right, so on number 2, we're going to do the exact same thing. The only thing that's changing is our base is different. We're going to rewrite it as an exponential. So my base is going to be 3 to the what power? 3 to the y equals x. So I'm plugging in y values.
Wait, so on the first one, why did,
You okay?
well, on the first one, why didn't we put y either?
We did.
We did? I put it.
2 to the y.
Okay. Okie dokie.
All right.
Same page.
So now I'm plugging in -2, and it's for my y. So it's going to be 3 to the -2. 1 over 9. Good. Now let's plot points.
Yeah.
Wait, how are you writing? Oh, wait.
How does the graph compare to log 2x? It's smaller. It's a
What would you call that?
horizontal, vertical.
It's a horizontal vertical. It is small. I'll take smaller. It's a little bit
Horizontally.
compressed.
vertically.
Yeah, it's a little bit shorter or vertically compressed.
Right down horizontally.
What?
It's horizontally and vertically.
It could be considered maybe horizontally stretched.
Oh, that's what it means, horizontal.
Now, I say that, but that wasn't caused by a transformation. It was caused by the base, by the difference in the base. So it is a little vertically compressed compared to the one above it, but it's not a vertical compression that caused that. It's because the base is different. So, okay, so now we have another one. Let's see, let's rewrite it. This is going to be 1/2 to the y equals x. Alright, so if I plug in, the first thing I'm going to do is plug in -3. So if I have 1/2 to the -3 power, then I can actually flip this over and make it 2 to the 3. Right? Because they're unhappy. They're both unhappy where they live, the 1 and the 2, because they're parentheses. So if I flip it over now, they're both happy, which makes this 8. So if I do 1/2 to the -2, that's 2 squared, which is 4.
And 2. Yeah.
Always.
1/2 to the -1 is 2. Anything to the 0 power is 1.
And then, isn't it 1/4?
1/4, 20.
Yeah, that's right.
Okay, so now we have to plot and graph.
Wait, what? Huh?
The asymptote is 0.
Is it that?
Yep.
Is it real?
Mhm.
Is it?
Mhm.
You sure?
So how does this one compare?
It's x-axis flip across x-axis, and also it looks like it's a vertical stretch.
If you compare to the first one, it's just flipped.
Oh, yeah, my bad.
So use.
Is everybody okay?
Maybe freaking curve Cartesian quizzes.
Alright, so rewrite this function and then solve it.
Oh, there's
So go ahead and rewrite it real
so
quick.
it's 2 to the power of y equals x minus 3.
Is it done?
Yeah, that's stupid.
Yeah, done?
Yes. So why don't I actually make it? Why is there 2 blanks for it? Does it want me to do the 3 part on the
It
second one?
says right there, add 3 to both sides.
Okay, so, alright, so 3 plus 2 equals x.
Alright, so now we are going to plug in -2, where y is.
3 plus
So I've got 2 to the -2 plus 3. That's going to be 1 over 2 squared, which is 1 over 4, plus 3. So that's
13 over
3 1/4. We have
Oh,
to,
we're gonna do 3 1/4.
the only reason I am doing that, and no, you're good, because I would have normally done it in proper fraction. However, I have to graph it. So if I'm going to graph it, I need to know where that's going to be. So it's going to be at 3 1/4.
3 1/4.
All right, so now we're going to do 2 to the negative 1. So 2 to the negative 1 plus 3.
1 over 2.
That's 1/2 plus 3. So
1 plus 3. 4.
2 to the 0 plus 3. 1 plus 3, which would be 4.
7. 4, 8, 8,
2
11.
to the 1. That'll be 5.
Put the double O. This can't even go all the way to 11. What's the point?
Get done. What's the point?
It's 15 to the right 3. This one's gonna be shifted left 4.
Get done.
Yeah. So it's 2 to the power of y equals.
All right, so I'm going to rewrite it exponentially. So I got 2 to the y equals x plus 4. And then it says add negative 4 to both sides or subtract. Bless you.
Oh, bless you, bless you.
So
Thank
I
you.
have 2y minus 4 equals x. Now I'm plugging in.
So that's gonna be a solid
So 2 to the negative 2 is
4.
going to be 1 fourth minus 4, which is going to be negative 3 and 3 fourths.
Then this next one's gonna be negative 2. Oh wait, no. I lied.
So 2 to the negative 1 minus 4, that's going to be 1/2 minus 4, which is negative 3 1/2.
Get done. What's much of it?
2 to the 0
Negative 2.
minus 4 is 1 minus 4. Is negative 3.
Huh? Oh, that's fine.
2
2
minus
to the 1 minus 4 is 2 minus 4 is negative 2.
4 is 0.
And 2 squared minus 4 is 4 minus 4 is 0.
Whoops, I'm mad at that. I'm gonna calculate it wrong.
Hispanic.
There's the couple. Rest in peace, my boy. That's, he looked like he was in quite a bit of pain.
Did he?
Is everybody good so far?
Imagine if that happened to you.
So
Moral of the story, it's
do
like
number
the same.
6 on your own.
Moral of the story is, where do we make this?
Oh, well, this is weird. How would you do it like that?
How is that?
Read what it says in parentheses.
Add -3 to both sides, so it's gonna like. But it'd be the exact same as the other half.
Yeah,
so
what's the difference?
No,
How?
read what it says.
Add -3 to both sides.
Then rewrite. Is what it says.
So how's it different than the other one?
Do it and see.
Alright.
No, it isn't.
2 to the power of y minus 3 equals x?
Yeah.
How's that different than this one where it was in the parentheses?
It's absolutely not the same.
No.
Because the y minus 3 is up in the treehouse.
Wait, what?
How did
Because it said, it says add -3 to both sides
Yeah, you have
before
to
you
do it.
rewrite. Okay, so if I do it before I rewrite anything, if I follow the directions and I do it before I rewrite, that's subtracting 3.
What told you wanted
So I have y minus 3 equals log base 2 of x. Now, if I go to rewrite this, the base is 2. These two things swap places, and this becomes your exponent. Y minus 3 equals x. It is absolutely not anything like what we've already done.
The instructions never said put it in the treehouse.
The instructions said do it before you rewrite it.
So how would I know it's going up there and not just
Because everything that's on that side is what goes up top. That's all we did yesterday.
Oh. But then when I rewrite, what's the point of rewriting then? What's your rewrite looking like? The exact same thing?
I already did it.
2y minus 3 equals x?
Yes.
Okay, I got it.
You got it? You sure you got it?
No. You got
Oh. You start breaking down. You start crying.
So the first one, 1/4.
Mhm.
Yes. 1/2.
Yeah, that one?
1.
Can you, like, okay, never mind, I did that. I was gonna ask you to
Two.
solve do the fraction thing.
Oh, it's 29.
Huh? 29. What?
Whoa, what are you on right now?
How'd you get 29? In what world did you get 29?
Yeah, I did not get that.
Oh, my bad, I did that wrong.
I don't
I don't know why I did that.
29.
I accidentally did that before I did the subtraction for some reason. My bad, did that.
300,045. You got that right?
I got the letter N.
How does this compare to the first one we did?
It is raised by
It's up 3.
1.
Did you just say 1?
This is Mohammed Mays Russian.
1 times
Yeah.
3.
I don't know if you want to go back.
Yeah, I meant 3.
Are you making a test?
Yeah.
Wait, Toby, you have to fill out a. Wait, Toby, hold up.
What?
I was joking. Yeah. I'm not willing to what? Do you know who Nelson Mandela was, Braden?
What?
Do you know who Nelson Mandela was, Braden?
Yeah, you know.
Yes.
calculator. So remember, the log button on your calculator is common log, which is log base 10. So if you look at the top, it says anything that's log base 10 you can graph in your calculator. So they gave us a window, so change your window to what they've given you.
What'd you say? Oh. Yeah, what did you say?
And we're just graphing log x, so it's log base 10 of x. How does this compare to the graph of log base 2? Or even log base 3?
It is horizontally not as high.
Not horizontally.
Oh,
what?
I got it.
Vertically.
It's a horizontal compression.
No, it's a vertical compression.
Yes.
What's the difference between?
Do you know the difference
Gotcha.
between vertical and
Yes, I
horizontal?
know the difference, but
Do you know what compress means?
yes,
Okay.
but
So,
it's making
okay,
it
wait.
like flatter out though.
Okay, so wait a sec.
That's vertical down.
Wait a second.
Well,
Okay.
wait, she has-
So if I have this thing, right, and I horizontally compress it, it would get taller.
Okay. Yes.
So
And
if I vertically compress it,
Okay.
it gets flatter.
All right. I was thinking coming from the top
All right.
too. All right.
Okay.
That was a very good analogy.
Yeah, it was honestly a very good analogy. That made all my confusion go away.
Okay, now, what is that?
You see, I'm doing the text like.
Can we go back to the last 6 weeks? I was doing a lot better then.
Okay, so now they want us to type each of these equations. So notice over here on 8, they have a y1, a y2, a y3, and a y4. They want us to put them all in and see how they're different. So you can either, when you go to plug things in, you can either back up all the way to the little dotted line over there, and you could change it. Like if I hit that, it's going to be bold. If I hit that, not that one, or that one, but that one, it'll be dotted. Or the other thing you can do is just when you hit graph, make sure you're watching it. It'll graph them in the order that you put them in, so you'll know which one's which.
I just keep pressing attention.
Turn it on me.
You right now, you're crazy. The workout this morning, we ran so much.
Yeah.
Like we did the third man, we had to like sprint 30-yard sprints or stuff.
Yeah.
Yeah. You like running right now? Seem like a running type of guy?
Quite the runner.
Dallin, you love running?
I was actually
No, I hate running.
What do you mean?
I was a lot better at it when I was like 40 pounds lighter, and I don't know if it was like, hey, you be a lineman. I was like, all right,
Hey,
whatever.
Dad, you look a little bit small.
Dallin, how would you like to be the heavyweight? No, I'm good. I wasn't asking.
I was telling you.
He didn't give you an option?
It was like option quotation marks. He's like, Jennifer, you're looking big. Maybe we should make you the heavyweight. And I was like, oh, that's funny, Coach Boo. And he's like, talk with me after practice. I was like,
Okay, what do they have in common?
well, what do they have in common?
They all-
They're all exponential or whatever.
They do. They have one huge thing in common. That
That's
is,
what
that
I
is true.
said.
But one bigger than that.
They have the same asymptotes.
They're all
You already
lines.
said they're all related on the color wheel.
Same.
Nice.
One's flipped.
They all pass through the point 1, 0.
my
Grab one
graph
and
on
watch
my
Raising
computer
Horses.
just say this.
I think all of our reasons are valid.
They're all lines.
How are they different?
Well, one of them is flipped across the x-axis.
Good. One is reflected across x, and then what about all of them compared to the first one, compared to log base 10? They are all what?
Different, like.
Let's see if I can get this right.
Different, like.
They're all
Vertical stretches.
yes, they are all vertically stretched.
Okay, well then what's the difference between a vertical stretch and a horizontal or compression then? Because wouldn't that just make
Oh, okay. That
Wouldn't
is
make
a
the
good
same
question. With this kind of graph that has arrowheads on both ends, visually you can't tell a difference.
Okay.
But second semester we'll start, which is why in Algebra 2 you don't deal with any horizontal stretches or compressions.
Yeah, we do.
They tell you about it, but anything they give you is always a vertical change.
Yeah.
Because you can't tell the difference because all of the parent functions you do in Algebra 2 have arrowheads on both ends.
Yeah.
When we get into second semester, we're going to get some new parent functions, and you'll be able to see the difference between a horizontal compression and a vertical
Oh,
stretch.
okay.
But right now you can't, so that's a good
Alright,
question.
Okay. So for right
That was
now,
one of
they're
your
just
better
all
questions.
That was a really good, all questions are good questions, but that was a
They
really
say that.
insightful,
And I
right?
judge you.
Maybe I'm not retarded.
Okay, so they are vertically stretched.
Yeah,
So
yeah,
even
you're
the
right.
one-
Yeah, you're right.
Even the one that's flipped is also stretched because it is farther away from the x-axis than the original. Even if my original one is green, so even if it looks kind of black, but it's green. Even if I flipped that green one over, it would be closer to the x-axis. The pink one is the reflection. It's also been stretched, so they're all vertically stretched, and one of them is also reflected.
That's so strange.
Are we out of time?
We are out of time. Yes,
Oh, gosh.
Darn.
I know.
My favorite class is over. What are we gonna do now?
Hey,
Go home
he's got to
and
empty his
sleep.
bowels.
I found two. I don't know if I should eat this.
Do we have anything?
What do you think? Should I eat this?